Well, good morning and welcome everyone. My name is Craig Zamary. I'm a business consultant here at the SBDC, which is the Small Business Development Center at YSU. And we're thrilled to kick off today's session, which is part one of a three-part series on exploring technology transfer and commercialization. This will be an exciting session, and the purpose is to help you learn about how to license the technology from a university and then how to take the next steps and start executing. I'm going to give a quick example. If anyone has ever heard of an app called Duolingo, it's a language learning app. I have it on my phone. I use it quite regularly. That app was created at Carnegie Mellon, and then it was licensed out and formed as a company, and they went to the market, and it's now a $1 billion company. So today we're going to show you some examples of these types of technologies. And before I introduce our guest, we'd like to provide just a quick outline of today's session. Meghan Hayes from Carnegie Mellon will begin with a short presentation, and then we're going to take just a brief strategic pause and open it up for Q&A. My teammate, Jenna Binsley, will be monitoring the chat and the Q&A, so please drop any questions you have in there, and Jenna will get those to our guest speaker. After the Q&A, we will bring up Carnegie Mellon site, and we're going to do a very interactive search, just a real-time search, so that you can see how we find technologies, and we're going to teach you how to do that so you know how to take the next steps. We think you're going to be really surprised to see some of the many really cool innovations that you can license. And then finally, we'll do a brief Q&A again, and then a summary of the session. So with that, let's begin. We're super excited to welcome Meghan Hayes, Associate Director for Center for Technology Transfer and Enterprise Creation at Carnegie Mellon University. Her role includes full cycle, comprehensive management of technology transfer activities, ownership of IP, which is intellectual property discovery, diligence, patenting, budgeting, license strategy, evaluations, negotiations, compliance and mentoring to junior licensee staff, arising from CMU research programs, principally from the National Robotics and Engineering Center and the College of Fine Arts. Meghan, at this time, I'd like to turn it over to you.
Thank you, Craig, and thank you all for being here to listen and learn about university tech transfer today. I hope everyone attending will gain an understanding about what tech transfer is and how available university IP could benefit their organization, and how to access university tech transfer offices. So with that, we can dive into what is university technology transfer. So a high-level definition of tech transfer is the transferring of rights, or really the granting of permission to use the intellectual property developed at the university to other entities. The goal is, and always has been, to better society, the economy, and the local region of the university by exploiting the fruits of research. I've included on here a brief glossary of terms that are often used in this field and this presentation. So those include intellectual property, or IP. It's a form of property under our law, but that property is in intangible creations of the intellect. They are exclusionary rights, meaning that if you have such IP rights, you have the right to exclude others from using or doing that type of intellectual property. The way we protect them under our law, you've probably heard are familiar with patents, copyrights, trademarks, and trade secrets. Another term that I will be using a lot is license. It's a legal document. It's the document that grants permission from the university to another to exploit or use that intellectual property. And then I also want to highlight the Bayh-Dole Act. This act was an amendment to the Patent and Trademark Act. It was enacted in 1980. To highlight the important parts is that it gave the universities the ability to own patent, and license the IP from federally funded research. It promotes commercialization, and to highlight of importance today, it also has requirements in there for US-based manufacturing and labor and small business preferences. So it's the system is set up for this type of interaction. And we can move on now to talk about my office, in particular, the Center for Technology Transfer and Enterprise Creation. We call it CTTEC. We are tasked with managing the university's intellectual assets, including their dissemination and transfer for commercialization. As mentioned previously, the vehicles for this are license agreements, and they come in various forms, and we specifically prepare and negotiate those documents to give permission to outside entities to use CMU's intellectual property. And these other entities include other academic and research institutions, as well as newly formed spin-offs, and our focus today, third-party commercial entities. In our office, we also oversee the protection of university IP, so we manage the patenting process, and we play a role in CMU's compliance with sponsor reporting in cases of both government and industry funding. So what tech transfer looks like. Move on to the next slide, please. Thank you. So almost every path to commercialization and every deal or license is different based on the technology, the stage of development, and the industry. Different technologies require different IP protection strategies. Different industries have differing paths to market, which then result in various licensing structures. But they all start at invention or creation at the university. The researchers then disclose that IP to our office, and we assess the technology and develop plans with the creators or the industry sponsors or the potential licensees for a commercialization strategy. What we're licensing is the intellectual property. And on the next slide, we can talk about the many forms it comes in. I'm sure most of you all know this, but it's a friendly reminder that IP comes in many forms: hardware, software, compositions of matter and processes, machines, designs. We have the chimp robot on the left there. He lives at NREC. And he probably encompasses all of those, right? From the hardware of the robot itself, and then the software and the programs that make it run. And we can now talk about what IP is generated from research on a university. Again, it comes in all of those forms we just talked about. I included a picture of CMU. It's an aerial view of campus on a nice sunny day. And it's there to serve as a reminder that the university is comprised of 7 different schools. So we have the School of Computer Science, the College of Engineering, the Mellon College of Science, Heinz College of Public Policy, the Tepper School of Business, and Dietrich College of Arts and Humanities, as well as the College of Fine Arts. So we have many types of IP in the various forms in many fields, including hardware, software, and data. That's a big one. So if we now that we know about all of the IP, why would you license it? We can move on. Sorry, Jenna. Thank you. And the answer is because world-renowned researchers who are experts in their fields, which may also be your field, are in their labs producing IP every day. This technology and innovation is out there. And like the slide says, licensing it is good for everyone.
But seriously, the Bayh-Dole Act that I mentioned on the first slide led to the creation of university technology transfer with the goal of getting the fruits of research into industry so that it can benefit society. And again, that act has specific requirements of preference for US-based manufacturing labor and using small businesses, licensing to small businesses. The infographic on the right is from Autumn, which is the Association of University Technology Managers. So it's a good resource to know because there's access to all of us who do this across the country. And the data is touting the impressive numbers associated with university technology transfer and licensing on the innovation economy of our nation for about the past 20-something years. And without getting into just reading numbers off of a slide, I just want to highlight that this opportunity is out there and the benefits are concrete. So take advantage. And on the next slide, we can review some of those success stories. These ones are specific to Carnegie Mellon CTTEC. So these are successes out of CTTEC. As Craig mentioned, we have spin-off companies, including those recognizable because of their mass appeal, like Duolingo, and then Marinus Analytics, which is currently a finalist in the AI XPRIZE, and we're very proud of that. But we also have situations where some of our smaller companies are acquired by bigger companies. And then we have license deals. So companies that exist that license CMU's technology, including this behemoth cat mining dump truck, which has some CMU technology aboard because mining is a dangerous line of work, and there's technology on there to make it safer. And then from that monster down to the cute little Sensibot that Shell has licensed for oil and gas equipment monitoring. Another safety aspect is that, this little robot can get to places humans cannot and validate the safety of the equipment in the field. And on the next slide, we have the facts and figures of CTTEC. We publish these every year, but the important things that I want to highlight for today are the 200 to 300 IP disclosures that we receive from our researchers every year. And we file nearly that same number of patent applications. So this is just a plug to say we have intellectual property. If you want to learn more about it, on the next slide, I have some information on how to work with us, how to get to know what intellectual property the university has. I've included our website. That's obvious, but on there we have the contacts, my colleagues. So who in my office handles which schools and departments. So who's the best person to reach out for your particular interests. We also provide our template license documents. These are our starting points for all of our agreements. And so if folks just want to get comfortable with knowing what a license looks like from a contractual and legal perspective, we are very upfront with them. We put them up there and are open to questions about them as well. We also include a link to our CMU Flintbox site, which we're going to take a look at that in just a minute with Craig, but just of note that this is a selection of our available technologies. It is by no means exhaustive. So if you get on there and you're not finding what you're looking for, I think the third bullet point might be the most poignant, which is to say, reach out. Find the contact on the website, start the conversation about what technology you're interested in learning more about. Or if you see a press release or a research article from a professor on campus and you say, wow, that's really interesting technology, reach out to us and maybe we can put you in contact with that professor, or we can tell you what that researcher already has available. So it really is about starting the discussion, because a license is a discussion. It's a back and forth. It's a plan where we work together. And I know that I'm probably biased based on where I'm from and the technology I currently work with, but our region is uniquely poised for this new big push in technology advancements in vehicles and manufacturing and healthcare and AI 4X. And it's our history, it's what we know, and I hope we can work together to benefit our region. So thank you.
Megan, thank you very much. That's very helpful to get that high level view, and it's exciting to hear all the work that's going on there. As promised, we wanted to take that strategic pause right now and just see and check in with Jenna to see if there's a couple questions before moving on, where I kind of go online and show really how the interactive part of searching for these technologies. So Jenna, I'll go ahead and turn it over to you.
Yeah, so looking in the chat here, so we had the question about approximately how many technologies are available to license from Carnegie Mellon University?
Yeah, so on the Flint box that we're about to go see, I think there's like a couple hundred on there. And then as I said before, we get about 200 to 300 new IP disclosures every single year. So cumulatively, we have thousands of dockets of intellectual property, and in all the various fields, which is why it's helpful to get the conversation started.
That's great. And so another question too we have is, who can license a technology from Carnegie Mellon University?
That would be anyone that the US government allows us to, that it's legal to, but so that would be, you know, we, as we said before, Duolingo started as a newly formed company. So these newly formed spin out companies with 2 to 3 people, all the way up to the behemoths like Cat that we all know. So, and everyone in between. So anyone that's interested in commercializing our technology.
That's great.
Great. Can you hear me okay right now, Jenna?
Yes, we can.
Okay. All right. Well, what I like to do right now is just to show everyone some simple ways to go in and search. So you go into Google, you could put in Carnegie Mellon, tech transfer, technology transfer. You can do this with other universities across the country. And so again, we wanted to make this interactive and show you just how to do this. So you'll see this part here. This is their main site for, and then there's inventors and researchers. You want to click on industry. And then over here is search available IP. And as Megan mentioned, IP stands for intellectual property. And this has the, again, it's showing some of the technologies that are available here. I'm going to go in here just like a Google search. I like to eat, so I'm going to just go ahead and search food. And you'll see this is a technology where it gives you a description. It's called FitBite, robust diet monitoring using sensor-equipped eyeglasses. So the abstract will give a little description of what it is. And it says it's a monitoring system designed to track when a user eats or drinks, what do they eat, and estimate the quantity of food. So really interesting technology. There's some pictures there. There's some publications that you can pull up. So if you want to take a deeper dive and kind of go through and look at this and read up a little bit more and say, wow, this is something that I'm really interested in learning more about, then you can go ahead and do that because they have it there. There's also a link for just a short video. Can you hear that okay, John?
Monitor one's diet. One of the most common tools is journaling, but current journaling methods rely heavily on self-reports that suffers from low adherence and recall errors. Introducing FitBite, automatic diet monitoring in unconstrained situations using multimodal sensing on eyeglasses. The design of the device contains multiple different sensors. There is one IMU at each of A, C, D, and E. There are 2 IMUs at B, which contains 1 gyroscope and 1 4 kHz accelerometer. There is also a camera on one side of the device and a proximity sensor on the other side.
How it is, which maybe are you they're also excited for that. Yeah. There are a lot of like fan theories. Like, many of them are already covered. You mean parallel tomorrow? Yeah, even the Captain Marvel movie is interesting.
You can wear the Fitbit eyeglasses in the morning when you wake up. Wear it to school, do work, and eat meals and snacks. At the end of the day, you can get a summary of what you ate during the day with the Fitbit mobile app. Fitbit can also allow medical researchers to investigate eating behaviors from the data collected, draw meaningful conclusions, and promote people's health and well-being. For more details, please refer to our paper.
So I'm going to go ahead and show one more through another search and go back. And this time I'm going to search Jim. Okay. And this technology comes up. It's using a camera to detect, recognize, and track multiple repetitive exercises simultaneously. So it says the Gym Cam tracks exercises not possible by wearable monitor. So that means it's, you can't do what they're able to do with either your Fitbit or Apple Watch, and it tracks the whole body motion. So again, there's a little area here where it gives the abstract. It talks about the benefits of this technology. Market application, it has on here exercise, single point sensing, health sensing, computer vision. I'm going to go ahead and click on this video too, just again, it's going to be for about 2 minutes, just to kind of, so you can see a little bit more about this technology and see if there's some applications that you might find interesting on here.
Fitness tracking is on the up and up. Estimating step count, keeping track of the heart rate, and custom applications to track number of repetitions for strength exercises. Wearables are the most commonly used device for exercise tracking. However, there are many exercises where wearables fail because it only looks at the motion of the limb it is worn on and is unable to accurately capture movements of other body parts. We present GymCam, a lightweight camera-based automated system to track and recognize exercises for hundreds of users at the same time. The most intuitive approach for such problem is to track the poses for each user. However, occlusions and noisy data make robust pose tracking extremely hard. So, GymCam looks at motion. It relies on the intuition that every repetitive motion in a gym is likely to be an exercise. First, we track the movement of thousands of points in a video frame. We look for repetitiveness in their motion over time and classify them as exercise or not. We use several features, such as frequency and phase, to cluster similar points together. For each exercise cluster, GymCam can now provide analytics such as repetition count and exercise type for hundreds of users at the same time. Okay, GymCam, start tracking. How many repetitions did I do?
You did 5 reps.
What's my next exercise?
5 reps of crunches.
from a smartphone in your house to hundreds of users in a public gym. GymCam can help track exercises anywhere, anytime.
So again, really just wanted to show that, again, whether it's Carnegie Mellon University's tech transfer site, or if you went into MIT, Yale, or any other colleges throughout the country that have tech transfer offices, you can look, find, and search technologies and see if there's an application that fits and aligns with your strengths or your interests. The gym one here is a great example of maybe folks are in this space right now and they want to track in their gym how the customers are using certain equipment, and maybe should they get rid of certain equipment or add more or change up the space. Someone might be watching this webinar today and say, boy, I'd like to look at licensing this type of technology and take it to Orange Theory or Planet Fitness and someone else to be able to give them some really intelligent data based upon how their customers are interacting and using equipment. It might have a military application that someone is interested to see how the training is in boot camps and other areas. So I think that these technologies were only limited by our imagination in regards to going in, looking and learning and finding ways to see if it makes sense to progress the conversation and turning it into a license. So I just wanted to show you a couple of those. And then let's say, for example, that you're interested in this GymCam. So the next stage would be to go ahead and here and hit contact, and you'll see Cindy Lou's contact information comes up. Put in your name, your email, your message. And then this is where I want to go back to Megan and just say, on a high level, what can our attendees today kind of expect once this message is sent? And what's the process like going forward?
Yeah, so Cindy is my colleague in my office who handles the intellectual property out of the School of Computer Science. So she would receive that email from you, and I would happily respond and get that conversation going. So the first question would be like, oh, thank you, thanks for your interest in GymCam. Could you present a little bit more of what your interest is? What is your commercialization plan? What does your business look like at this point? And then, do you want to speak to the researcher about your plans? Do you want to see if it is a good fit? It starts the conversation. It's always a conversation. And I do want to point out something like GymCam. Let's say you don't have a gym and you're not interested in exercising, but you do need some sort of computer vision technology for a repetitive motion. Look up that researcher. There's information on there. Google them, see what else their lab is outputting. Maybe their technology is a great fit for something that isn't, the need that they were addressing in that one iteration, especially with the, things like software that we have so much of at Carnegie Mellon.
Great, thank you very much, man. That's really helpful. Jenna, I want to go ahead back to you to see if there's any other questions at this time for Megan.
Yeah, so we have one here in the chat's asking, it says, can you explain the difference between an exclusive and non-exclusive license?
Yeah, so in our licenses where we give permission to another entity to use our IP, in some cases, it's what we call exclusive. Typically, there's a field of use associated with it. But in that case, that would be the only other entity we give permission to use that intellectual property. Obviously, the opposite is non-exclusive, where maybe we will license that same technology over and over again. There are different strategies based on types of technology and the market and the commercialization plan. Again, intellectual property is an exclusionary right, so it's a competitive barrier. If that's necessary for a commercialization plan or a business opportunity, then probably exclusive license is of interest. You could see that being the case in situations where the IP has been patented, right? Because that's the whole point, it's to create a monopoly. Whereas some software, that's subject to copyright, maybe it has a universal or generic application, and it's the use of it, not the keeping others from using it, that's of interest to the company. And in that case, then the path would be a non-exclusive license. And they have different requirements. Obviously, it affects the valuation of the IP and the license. Exclusive is typically seen as more valuable. But so again, it's very fact-based and specific.
Okay. And then another question we have, it says, are there other technology transfer offices at universities across the US that we can license technologies from?
Absolutely. We have a whole association. So again, that's the Association of University Technology Managers. We call it AUTUM. So all of these research-based institutions, there will be an office that handles and manages the intellectual property and its dissemination. Sometimes it's called a tech transfer office. Sometimes it's called the Office of Technology Management. Sometimes it's innovation management. There's different brandings like CTTEC out there, but yes, most of the research universities across the nation will have these offices.
Okay, and another question too, one of our attendees, they had a specific question. They wanted to know more information about the reporting requirements. They're currently looking at a technology that they would like to license. And so it says, I'm interested in to find out more about the reporting requirements we might accept as part of a licensing deal. And they said that they're a little bit hesitant to agree to the reporting of their company's financial details. So they didn't know if you had any info on this, on the reporting requirements.
So I'm assuming the reporting requirements from licensee to the university. Those are typical, especially in an exclusive license. So if the research was federally funded, then that is a federal requirement, because like the requirements on the university for a preference for US-based manufacturing, labor, small business, there's other requirements to make sure that the technology is indeed being used. So when we have to report that to the government, which means we need that information from the licensee. Typically, though, that is considered confidential information under the license agreement. There's a whole section on confidential information. So if that's the concern, I know on our license agreement, we have sort of a standard form on how to fill out that reporting information, what we're interested in. And there are things that can be redacted if that's the concern.
Okay. And currently, I think that wraps up for Q&A currently, but if anybody has an additional questions too, feel free to put them in. And I know too, you have our emails too to reach out following.
Yes, absolutely.
Okay, well, Megan, we truly appreciate you taking the time to help our attendees learn more about how to license the technology from a university. We wish to thank you and Carnegie Mellon University for your time today. Also like to thank Jenna Binsley for designing all the digital materials and setting up these sessions, as well as Cody Allen and Pat Weiss, the director of our SBDC, for having this session, this programs available for our clients and others. Thank you everyone again for attending today. Please join us tomorrow at 11 a.m. We're having another session. That session will be focused on NASA and licensing technologies from NASA. And then Friday at 11 a.m. on leveraging government funding and technology expertise for businesses. So again, thank you everyone, and have a great day.